Hello and a very good day to all of you. Welcome to the lecture series for BDA 14303 Fundamental of Electrical and Electronics Engineering. My name is Dr. Muhammad Akmal bin Johar and I will be your instructor in this video. In this video, we will learn Thevenin Theorem for circuit analysis. So let us take a look at the learning outcome of this video. At the end of this class, the students should be able to understand the fundamental of Thevenin's theorems, understand the steps required to perform Thevenin's circuit analysis, and finally, able to apply Thevenin's theorem to solve electrical circuit analysis. So these are three learning outcomes that students should be able to grasp at the end of this lecture. As we all know, there are two general approaches to network analysis. The first one, we have learned several methods in using direct method, and the second one is using network reduction method. So in network reduction method, one of the techniques that we will use and learn in this course is Thevenin theorems. The first question is, how can Thevenin theorems help us to solve network analysis problems? Imagine we have a complex circuit that requires simplifications, and Thevenin theorems will help us to simplify a complex linear circuit and converted it into an ideal voltage source and resistor. These new calculated components are called Thevenin voltage and Thevenin resistance. In simple words, we can say Thevenin's theorem states that for any circuit of resistance elements and energy sources can be replaced by a series combination of an ideal source, voltage Thevenin, and a resistance R Thevenin. This voltage Thevenin is the open circuit voltage at the two terminals, while the R Thevenin is the input or equivalent resistance at the terminals when the independent sources are turned off. To implement Thevenin circuit analysis with independent sources, there are 6 steps involved. First, we need to identify circuit A and circuit B. What is circuit A and circuit B? Circuit A is the part of complex circuit that requires simplifications, while circuit B is just simply the load of the circuit. The second step is we need to separate the circuit A from the circuit B. Here, we took two terminals that separate these two circuits and name it as a Thevenin terminals. The value of Thevenin voltage and resistor are based on these Thevenin terminals. So in the third step, what we need to do is we need to determine the value of our Thevenin resistance. How we can do that is fairly simple. What you need to do is we deactivate all the independent sources inside the circuit. So if you have voltage source, what you need to do is you replace it with a short circuit, and if you have current source, what you need to do is replace it with an open circuit. This is similar with the technique that we have learned during superposition theorems. Only during this time, we do it at once. And for the step number 4, what we need to do is we calculate and determine the value of Thevenin voltage. In order to do this, you have to calculate and look what is the voltage from the port AB in the point of view of port AB. So you can always use the previous technique that we have learned, such as mesh techniques, nodal, and any other technique in order to determine the value of Thevenin voltage. Once we have completed step 3 and 4, where we have obtained the value of voltage Thevenin and Thevenin resistance, now we can replace the circuit A with this new Thevenin circuit. Final step is we can reconnect circuit B with the new equivalent circuit, the one that we have calculated in the previous steps. So those are the 6 steps that you need to perform in order to determine or use or apply Thevenin theorems to simplify or do manipulation in the circuit theory. Next, we will take a look at least 2 examples on how to implement Thevenin's theorems in circuit theory. So in this first example, the circuit already given in the form of circuit A only. So students don't have to determine which part is circuit A and circuit B. So all you need to do is just straight away determine the Thevenin's voltage and Thevenin resistance of the circuit from the point of view of port A and B. So the first step to solve this problem is we need to find the Thevenin voltage. And in order to do that, we need to determine is there any node available in this circuit. So I can say that we have node 1 and node 2 over here between the resistor of 220 ohms and 470 ohms. And here we have from node 1 to port A, we have 1 kilo ohm resistance. And since in these situations there will be no current will flowing to this path, so 1 kilo ohm will contribute nothing towards the Thevenin voltage. So we can say the voltage of AB across port AB is equal to the voltage drop across node 1 and node 2. So using voltage divider rules, now we can easily determine what is the V Thevenin, in which the voltage drop across 220 to 470 ohms. So the voltage Thevenin is equal to 470 plus 220 divided by 1 kilo ohms plus 470 plus 220 ohms times 10 volts. And this gives us the value of 4.08 volt. Voltage source using short circuit and current source using open circuits. Next, here it will become, in this situation, the circuit will be, if we withdraw the circuit, it will becomes like this, where you have 1 kilo ohms and 1 kilo ohms in parallel with the 220 ohms and 470 ohms. So there is no current source in this situation, so there will be no open circuits. And then from here, easily we can calculate the R Thevenin between port A and B is equal to our 1 kilo ohms plus the parallel of 1 kilo ohms and 220 ohms and 470 ohms, and this will give us the total value of 1.41 kilo ohms. Then finally, we need to withdraw the Thevenin equivalent circuit into the these two value of Thevenins, which is 4.08 volts in series with the R Thevenin 1.41 kilo ohms, and then we just replace and connect it to port A and B. So next we'll take a look at the example number 2. Here also we have a kind of similar question from before, and also we have to find the Thevenin equivalence at port of AB, and only this time we have the voltage independent sources of voltage source and also current source. So similar to previous, then we need to do the first step is to determine the Thevenin theorems, the voltage Thevenin. And in this case, when we look at this situation, it is much more suitable to use a nodal analysis. I would like to propose to you to use nodal analysis in order to solve it because of the nature of this circuit. And using the nodal analysis, we can introduce a node VA here, and this node will be equivalent to node VA, so you don't have to introduce a new nodes, and we have a ground nodes down here, So all in all, what we need to introduce only one simple node of VA. Here, in order to determine that, we need to build up the equations of VA, in which you have three paths here from I1, I2. So we will consider I1 goes into the VA, and I2 will also goes to the VA, and I3 also come out from the point node VA. So the equation of a node VA can be written as I1 plus I2 minus I3. Similar to previous examples, we have the resistor 4 ohms here, in which it will not contribute anything towards the value of Thevenin in these situations. So here we can say that the Thevenin is the voltage across AB, or from the point of view of AB. In this situation, it is easily can be calculated from point VA and across these 20 ohms resistors. So if we're able to determine the voltage drop across 20 ohms, which means the VA towards ground here, then we can say that's the voltage Thevenin for the port of AB, because the 4 ohms will have no current flow through, and there is no need to there is no contribution or whatsoever from these resistors. So let's determine let's calculate the VA value here. So we have, as we mentioned before, using nodal analysis, we have I1, I2, and I3 into the VA, and the I2 will solely the 3 ampere here from the current source here, and goes into the I2 or VA point in the path of I2. So we can write down the equation from I1 plus I2 minus I3 equal to 0, and this will becomes the equation of 25 minus VA, which is for this path, 25 minus VA divided by 5 ohms for I1, plus I2 will become a 3 ampere, a total of 3 ampere here, so we don't have to calculate anything, and then minus VA minus 0 divided by 20 ohms. Then this will give us the equivalent of 2 equal to 0. And then from here we can rearrange 3 plus 5 minus VA over 5 minus VA over 20 equal to 0, and solve this, we can get at the end of the day VA is equal to 32 volts. And this VA is equal to 32 volts. This gives us the value of the voltage Thevenin in these situations. So the second step, what we need to do is to determine the R Thevenin, and similar to previous one, we have in this situation 20 volt and 3 ampere. So we need to deal it at the same time. Here, we replace the independent source for the voltage source to short circuit, and the current source into the open circuit. So as you can see here, the current source here will turn into open circuit, and this voltage source will turn into a short circuit. So we need to withdraw the circuit spec, and now from there we can able to determine the value of R Thevenin fairly easy. Here the 5 volts and the 20 ohms, the 5 ohms and the 20 ohms are in parallel situation, and those two parallel resistors will be in series of 4 ohms, and that gives us the equivalent resistance of port AB, in which similar to R Thevenin. So R Thevenin is equal to 20 parallel with 5 plus 4, because these will be in series. And finally, when we calculate all this, we will get the R Thevenin is equal to 8 ohms. Finally, I would like to share some notes for these Thevenin theorems. The Thevenin equivalency really depends on the viewpoint of the questions. It can be terminal from point A and B, or B and C, and also between A to C. So please carefully read the questions, and from the question determine accordingly what is required by the questions. I end these sessions with this in-class tutorial, where I would like you guys to find the value of Thevenin with respect to the capacitor 1 nanofarads. So here you have the 3 volt independent resistors and 6 milliampere of independent currents, and please try to determine the R Thevenin and B Thevenin for this circuit. So with that, I would like to say thank you. So I welcome to all of you to just drop off any questions you have concerning this lecture, and in our Google Classroom portal, please feel free to drop any question if you have any, and I will try my best to really answer all of your questions. So I would like to say thank you very much. I hope you guys enjoy this video, and we will see in the next video of my lecture series. Thank you.